So again, this is where we left off. Okay, this is 1, 2, probably about the second or third page in your notes. All right, it starts with the Pythagorean theorem at the top of the page. So we're going to get into the Pythagorean identities. But before we get into those, I'm going to show you where it comes from. Okay? So I have that triangle drawn there, and I threw A, B, C on there, and I got a reference angle for that we're going to use here. But Pythagorean theorem, who can tell me what the Pythagorean theorem is? Anybody? There we go. A squared plus B squared equals C squared. All right? Probably one of the most common theorems that you have from math from your high school career. A squared plus B squared equals C squared, or leg squared plus leg squared equals hypotenuse squared, right? Now, looking at this thing, I'm going to simplify this a little bit, okay? I want to get this equal to 1. If we get something equal to 1, then it gets to the point that it tells us a little bit about it. So I'm going to take this C and I'm going to divide it out. I'm going to divide both sides by C squared, okay? So then that's going to give me A squared over C squared plus B squared over C squared. That's equal to 1. You good with that so far? Now, if I go over here onto the side now, I'm going to look back at my triangle, and the two most common things we're going to use is sine and cosine. All right, as we go farther on, sine and cosine are going to be the ones we're going to turn stuff into. It's going to be the ones we can work with. So I have a reference angle there of theta. So what's the sine and the cosine of theta? First of all, what's the sine of theta? Slash back for a second. What's the phrase you remember? SOHCAHTOA. Not SOHCAHTOA, SOHCAHTOA, right? SOHCAHTOA. All right, SOHCAHTOA. So the first one, sine is what over what? Opposite hypotenuse, okay? So here's my reference angle. What's my opposite side? A. What's my hypotenuse? C. Okay? Hypotenuse is across from the right angle. Opposite is the one that doesn't touch the angle. Okay? So we're going to have A over C. Okay? How about my cosine? Cosine is going to be adjacent over hypotenuse, so that's going to be what? B over C, yep. Now, if I look over here, back to that Pythagorean theorem I was messing around with, isn't that pretty much what I have? A over C, B over C? Pretty close, right? We just have squares. So I kind of factor that square out. So I can replace this guy with sine of theta squared plus cosine theta squared. That's equal to 1. See how I got that? So now I have something equal to 1. I have the sine squared of theta and the cosine squared of theta is equal to 1. Well, that's my first Pythagorean identity. I just wanted to show you where that came from. So I'm not just showing you that there's, this identity, just believe me. Okay, that's where it came from. One of the most common ones you have is sine squared of theta plus cosine squared of theta is equal to 1. And then from there, we can manipulate those around. And I can also have that sine squared of theta is equal to 1 minus the cosine squared of theta. Okay, I can subtract things back and forth across the equation. And then from this one, I could use this one to find this one and to find this one as well. Okay, but those are 3 givens. We'll use these a lot later on when we start to justify things. We're going to show that, the cosine squared of theta plus the sine squared of theta is equal to maybe the tangent squared of theta minus 2 cotangent, something like that. Okay, we'll use those properties later. But I just want to throw them out for you now, and we're going to use one of these for an example. All right, so we're going to use the Pythagorean identity to find the cosine of theta given the sine of theta is equal to 3/5 and theta is an acute angle. All right, so we know this And we're looking for this, right? So let's use Pythagorean identity. I have a cosine, I have a sine. Which one do you think we're probably going to use? Probably the one that has sine and cosine in it, right? Let's use that first one. Sine squared of theta plus cosine squared of theta is equal to 1. All right, we know the sine here, correct? So the sine is 3/5. So I'm going to have 3/5 squared plus cosine squared equal to 1. Right? What's 3/5 squared? 9/25. Okay. So now I'm just solving for the cosine here. All right, so let's subtract this 9/25 over. So I subtract 1 minus 9/25. Common denominator is going to be 25 over 25. So 25 minus 9 is going to be 16. So I'm going to have the cosine squared of theta is equal to 16 over 25. So we almost got it. We want cosine, but right now we have cosine squared. What do you think we need to do to both sides? Square root them. Absolutely. Square root both sides. I have the cosine of theta is equal to 4/5. Okay. In that case, we use the one of our Pythagorean identities. We also, if it didn't ask us to use a Pythagorean identity, we could have set up the triangle for it. Okay. I'll just do it this way real quick to show you it's the same. So if I say that that's my theta, sine is opposite over hypotenuse. This would be opposite. This would be hypotenuse. Find the third side. This is going to be a 3, 4, 5 triangle if you use Pythagorean theorem. So that would be 4. Now cosine is 4 over 5. Okay? So it's the same both ways. We just use a Pythagorean identity on the first one. Any questions on that? All right, next part. We're talking about trig functions and their complements. Now, if two angles are complements, if their sum is 90 degrees or pi over 2, this means they're paired together. Okay, they're going to be similar. If you remember back to 30 and 60, the 30, 60, 90 triangle, remember doing that the other day? So let's flash back here real quick. So 30, 60, 90 triangle. The sine of 30 is the same as the cosine of 60. Okay, cosine of 30, same as the sine of 60. Isn't 30 and 60 added 90? Yes. All right. So that's how they're paired together. That's what this cofunction thing is going to be all about. Complements and cofunctions. So a complement is they added 90. Then a cofunction is how they fit together. So like we just said with the 30, 60, 90, the sine is going to be the same as the complement of the cosine. Okay. In this one here, in your notes, there was 2 typos. These are all supposed to be thetas. And this is supposed to be cosecant. I think it came up. I think it rewrote as cosine. All right, I think it like auto-corrected. So just make sure that those 2 things are switched on your notes. But the value of a trig function equal to the cofunction of the complement of theta. Cofunction of the complementary angles are equal. We just saw that in the 30, 60, 90. All right. And anytime you have something that's in radians instead of 90, you just put pi over 2 in there. All right, so we're going to find a couple cofunctions here. You guys good? All right, so we're going to find the cofunction with the same value. So right there, I have the sine of 72 degrees. If I want to find the cofunction of a sine is going to be cosine of 90 minus that, right? So the sine of 72 is equal to the cosine of 90 minus 72. What's 90 minus 72? 18. Therefore, the cosine of 18 degrees would be the same exact value as the sine of 72 degrees. Okay. About cosecant of pi over 3. Well, cosecant is paired with secant. Okay, so cosecant would be, ooh, cosecant would be equal to the secant. Now I have radian measure here because I have pi over 3, so I need to make this pi over 2 minus pi over 3. All right, this just replaced my 90 degrees. Now I have to find a common denominator here. What's the common denominator of 2 and 3 going to be? 6. So I had to multiply this first one by 3, so it'd be 3 pi over 6 minus 2 pi over 3, right? 3 minus 2 is, sorry, that's over 6. It'll be 1. So that leaves me with just pi over 6. So the secant of pi over 6 is the same as the cosecant of pi over 3. Questions? All right with that? All right, I want you guys to try this one. I want you to try, I'm just going to give you, right up here, cotangent of 2 pi over 6. Find me the cofunction to the cotangent of pi over 6. All right, Maurer, what'd you get? 2 pi over 6, that's simplified any further? Pi over 3, and what function is in front of it? Tangent. So she had tangent of pi over 6, right? Pi over 3. What'd you have, Wilson? Derivative? Okay, good. All right, because we take this guy, that's equal to the tangent of pi over 2 minus pi over 6, right? After we do the common denominator, we get pi over 3. All right? Questions on cofunction so far? Still good? All right. Now, let's get to the fun stuff. First thing, everybody get out your calculator. Whatever calculator you have to use. Some of you guys have them, don't you? The one on your phone probably won't work. None of you guys have calculators like these?
I don't want to buy like a $40 calculator.
It's $9.
That's cheaper for
Climb back up on that table there, yeah. Like down. Okay. So we gotta be able to use these for figuring out your trig functions. All right, this isn't something you can do in your head, and most times with a calculator, phone calculator is not going to let you do it. All right, so I just want to do a little calculator work. I want you guys to know how to do this stuff, so come test time or quiz time, you're not sitting there going, "Oh my gosh, how do I change my motor?" All right, so if you guys have, you three are going to be the same. You might be just a little bit different. Oh wait, here, give me that one back. There's another one, same one, so we're all on the same page. Okay. First off, see that button? Second button in from the left says DRG. Yeah? Okay, go ahead and hit that. You hit that, you should get DEG, RAD, and GRD, right? DEG is degrees, RAD is radians, GRD is radiant. You don't have to worry about that one. So if you want to go back and forth between the two, you just scroll over and hit enter. All right, so let's go ahead, put it in, make sure it's in degrees. All right, so just make sure the degrees is highlighted and hit enter. And if you look down in the bottom right corner, it should say DEG. All good there? Go ahead, just type in cosine of 48.2. Cosine button is 2 above the 8. All right, go to 8, go up 2. Hit cosine 42.8 or 48.2 equals, what do you get? 0.666. All right, because there's no way I'm going to leave just 666 on the board. We put a 5 on there, okay? Everybody get that on your calculator. Yes? All right, try the sine of 72.8. What do you get there? 0.9553. What? Sine 72.8. I got 0.955. Oh, 27. So yeah. Yeah? I rounded off 4 decimal places. 0.95527.
I got 0.295.
Yeah, you put it in cosine.
Did you put cosine? Did you put sine?
Oh, my bad. I get it now.
Yes, cosine. You want sine.
I get it.
Come on, Reese.
Okay, you're right.
Of course I'm right.
No, you're wrong.
All right. So these are pretty easy when they're in degrees. If you have a degree right here, that means you need an degree mode. Okay? If you do not have a degree, you have either pi or a whole number like these next two. Okay? You have to put it in radians. So hit that DRG button again. Scroll over to the right one, hit enter. Now you should have rad down in the bottom right corner. Now, we got a problem though. So anything you have must be in terms of sine, cosine, or tangent. If you look at that calculator, do you see a cosecant, secant, or cotangent anywhere? No, you don't. Okay? Now, if we remember back to our identities, let's go back up here once. These are reciprocal identities. So if we have something that's the cosecant, that's the same as 1 over the sine. And so on, okay? We want to use those reciprocal identities to get this to a point where we can put it into a calculator. So cotangent is just 1 over tangent. So this would be 1 over the tangent of 1.2. Now we have that in a form that we can put into the calculator. So in that case, just do 1 divided by the tangent of 1.2. Tell me what you get. 0.388. Yeah, I agree. Anybody else agree? You're still on the last one. I want to see you get the right answer, yeah. I want you to prove to me that you know how to use a calculator. Yeah, rad equals, you're good. 1 divided by tangent of 1.2. You're still good. You're good. Yeah. 1 divided by tangent 1.2. There you go. Good. Nice job. Howard, you get it?
Yeah.
Okay. Good. All right. So we got 0.388, right? All right. Last one. Cosecant. What's the cosecant going to be? What's the reciprocal identity? 1 over the sine. Yep. Go ahead and try that one. What we get? Anybody? What?
What?
Yeah, I like that better. 0.0025.
Why am I in degrees? Did you say 38? I'm in degrees still. This is stupid. I literally went to rad.
All right. We all right with that now? We all able to get the 1.0025?
Yeah.
Okay, so that's how you use the calculator. Make sure, big thing is make sure you get your things in the right units. All right, honestly. Usually if you're finding cosine, sine, tangent, it's going to be something smaller. All right, probably 2 or so or less, most often.
So we get
How do you
38.
get that?
Oh.
Now, what's that?
How do you get out of this?
Out of just whatever one you want, highlight it, hit enter. All right. Now, the one other thing I want to show you how to do real quick is, so these are all our ratios. When we think about it, a lot of these ones were like 3 over 5 when we got the answer, right? Well, 3 over 5 is going to be 0.6. So that's why we're getting these small numbers. All right. Where you're going to get the bigger numbers at is when you use the inverse function. So let's just do one of those really quick. If you look at make sure your calculator's in degrees here. So we might have to switch back. Put it in degrees. Now, if you look at sine, cosine, and tangent, see the thing up above them? It says sine of -1, cosine -1, tan -1. You guys all see that? What those are used for is what happens if we don't have an angle. So like this first one, I have the cosine of 48.2 degrees equals whatever. All right? Sometimes you're not given the angle. So let's just say, let's use an example I just had. We'll use the cosine of theta equals 3/5. Now we want to find that angle. Now, common sense tells us that if we're solving for theta, we would divide by cosine, right? I mean, just think back to algebraic properties. Problem is, it doesn't really work like that. Okay, a sine or a cosine has to have an angle attached to it for it to work. So we can't just straight divide it out. What we have to do instead is what's called the inverse sine. Okay, so now I would have theta is equal to the inverse cosine of 3/5. So it's almost like you're dividing. So then in your calculator now, you would just do inverse cosine, be second cosine, 3 over 5. Make sure you close up the parentheses. And there you're going to get 53 degrees. Okay? That's how you solve for an angle. Use the inverse sines to solve for an angle. We're going to use that here in one of these problems down below. All right? Questions? Okay. Now here's the fun stuff. All right, this is the fun stuff. This is really the nitty-gritty of trig right here. We use the sine, cosine, tangent. Now we're going to use it to find missing sides and missing angles. So I gave you 4 triangles right here. First 3 we're missing a side. Last one we're missing the angle. All right. Now, most times before this, if we had a right triangle and we're missing a side, we use Pythagorean theorem, right? Problem was, you had to know 2 of the 3 sides. And number 1 here, I know 1 side. That's it. So I can't use Pythagorean theorem. But if I know 2 things, if I know a side and I know an angle, I'm in good shape. Okay? So when you're looking at this guy, the first thing you got to do is pick the trig function using the 2 items you're given and the one you're looking for. All right, so I'm given an angle. This is my hypotenuse. And then what side am I looking for here? This is my reference angle now. This would be the adjacent. So which trig function uses adjacent and hypotenuse? Cosine, right? All right. So we need to use cosine for this. So set up what you know. So now I know that the cosine of 39 degrees equals adjacent, which is x, over 38. Now from there, all we got to do is a little bit of algebra. I want to get x by itself, right? We're solving for x. How do I get x by itself? Yeah, it's multiply both sides by 38. Now I'm going to have 38 times the cosine of 39 is equal to x. Punch out the calculator, and what do you get? Should be in degrees. 5-degree angle. What'd you get? 29 and a half, roughly? Yep, I agree. 29.5 equals x. So I was able to find that adjacent side with a length of 29.5 based off the angle that was given and the hypotenuse. Kind of cool, isn't it? Okay. You know, I find this stuff very interesting myself. I spent a summer working at PennDOT where I was a surveyor. We used this. Okay, if we knew different distances and stuff, if we knew maybe one distance, then we were using the laser finder or the oh crap, what's the name of it? Transit. If I was using one of those, all right, if I know the distance maybe from me to him, okay, I know the distance from me to you, Woodring, and then there's a river here beside us, all right, but there's a point over there that I want to find, all right, so now if I'm here, I know this side, I'll make a right angle, I turn 40 degrees, I can find that distance from him to there, or the distance from me to there, using trig functions, even though I can't walk across that river, okay? Another example I used is back whenever we shut down for quarantine. All right, after a couple weeks of no school, I was nuts. I'm going to be honest with you, I was completely nuts. I'm like, I got to do something. So I decided I was going to build this. Okay, so I built this podium, and I kind of nerded out a little bit, I won't lie. All right, it happens sometimes. I mean, you understand. You live with a math teacher too, right? Does it happen? I don't believe you. Maybe she just doesn't share.
Well, she does, except I just tune
Oh, okay. All right, so I'm trying to build this thing, right? I know the height of the table. I know how high I want this thing to be. Now I was figuring out what angle I wanted this top to be at, right? So a lot of times for angles, you just kind of guess and check. Well, I knew I wanted this height, and on this height, then I was able to calculate this angle. And after I calculated the angle, then I was able to adjust my cutoff saw to the perfect angle. I was sitting there doing trig fun. Oh, it was so much fun. And then at the same time, I'm like, yeah, I just started out for no reason, you know? So, it happens. What?
So would it take you like a day, and then you're like, oh, gotta find something else to do?
Yeah, I think about this in about a day. So, I could have, but mine's nicer.
Stuck at home, I know.
I had nothing else to do. I mean, come on, it's full custom. This puppy's oak. This sucker's heavy. All right, this is just clear oak. You know, I took the oak boards, planed them down, jointed them together and, you know, painted it, stained it. Yeah, I mean, hey, we don't do
You did
stuff
the
half
tea
around here.
yourself, too?
I did the tea myself.
Wow, that's impressive.
Bad part is I broke it. You can't even tell, can you?
Yeah,
I dropped it.
can tell.
Where's it broke at?
Is it like a crack in there and you do?
Huh. Where's it broke at?
Let's try to look at it.
Oh, it's not.
Correct. It's definitely a crack. I can't see it.
Covered up pretty well, didn't I?
Look at the tall leaf.
Believe it's. Where did it go? It's right down through here. See, there's just a little bit in between the grains, and it cracked back through
You can't
here.
even see it.
I dropped it. I cut the thing out, and then I dropped it on the floor, and the thing popped off. There might have been some bad words said. Then I was able to glue it back together and restain it. We're good. So yeah, after this took me like a day or two, a day to build. Then I had to stain it and let it sit, then poly the next day. So I had to wait for dry time. Then I'm like, all right, now what am I gonna make? So I made like 2 signs that I have at the house. Then I'm like, all right, now what am I gonna make? Then I just gutted my living room and dining room and did a full remodel. I had to have something
My
to do.
mom did that to our kitchen.
Yeah, I went.
I came down one morning and all the cabinets were down. I was like, what the heck is happening? She's like, well, we're gonna redo everything. And I was like, as in me, you mean like me and Allie?
Yeah, so a couple days into the quarantine, I had to get out of the house for one day. I did a really nice job. I stayed home, right? And I had to get out. So then I went to the sawmill and took the trailer and got about $1,000 in wood and redid my whole house. But see, it worked out nice though, because I put like pine boards, like tongue and groove pine up on everything. And then I made all the trim. Instead of buying trim, I just made it all. Made all the trim. I built a desk. What else did I do? I don't know, I just went custom on everything because I had all the time. I built a door. Oh, it took me a month or so to work to get through everything. I'll show you some pictures someday. All right. Anyway, any question on that first one? All right, let's look at the second one now. So on the second one, I have a different sides that I'm looking at now, right? I still have the hypotenuse, but now it's a different side. It's not my adjacent side. What side am I using there? What side am I looking for? It's the opposite side. So now I'm looking for opposite side and hypotenuse. What's that going to be then? Opposite and hypotenuse is which trig function? Sine. Okay. So I have a sine of 32 is equal to opposite over hypotenuse. Go ahead and finish that one then. Take it to a tenth.
Like, I can round this one up. That makes it equal to round this one up.
What'd you get?
7.948.
7.9 works.
I didn't know if you were thinking like 8 because like you round 5.
7
I
point.
always really do
1 or 2. Yeah, 1 or 2 decimal places. Usually on a test or something, I'll specify. All right. But yeah, so you multiply both sides by 15, so you have 15 times the sine of 32. X can be 7.9. You guys all get that? Okay. All right, now the last two here, they're a little bit trickier. Okay, just slightly. So let's look at those. Number 2, it's really the third one, but number 2. So I have 42 degrees, X and 31. What two sides am I looking at on this one? Opposite and adjacent. So what trig function is that one? That's tangent. So that's the TOA right there, right? So in this case, tangent of 42 degrees equals tangent's opposite over adjacent. So what's my opposite side? 31. What's my adjacent? X. Okay, so now it's a little different because the other ones, my x's were on top, right? So now we still got to solve for x, so we got to get them out of the bottom. Let's multiply both sides by x. So I have x times the tangent of 42 is equal to 31. Still good? Get x by itself, so let's divide both sides by the tangent of 42. So now x is going to be equal to 31 divided by the tangent of 42. What's that going to equal? $34.4? I agree. 34.4. Still feeling good? All right, last one of the day. Let's find an angle. Okay, this one here, we're going to know two sides of the triangle. We want to find the angle now. So looking at this, I have my reference angle of theta down here. What sides do I have in relationship to the reference angle? Hypotenuse and opposite. So which one's that? That'd be sine, correct. So I have the sine of theta is equal to what? Opposite. There you go, good. 43 over 74. Now we just talked about this one. If I can't really, technically I can't divide by sine, what do I have to do in this case? What function do I use on a calculator? Inverse sine? Yep, inverse sine, correct. So the inverse sine of 43 over 74. Go ahead and punch that one in the calculator. Tell me what you get. $35 and a half. Good. And now that was theta. That's an angle, correct? So make sure you put your degree sign on the end. Any questions? Anybody? All right, we're going to stop right there for today.